Hi everyone, this is me Saurabh. Today we will look how RAG pipeline looks in production and how it is different from a normal RAG pipeline which you see in on the YouTube and everywhere else. Okay, so let's start. Thank you.
In 2026, companies are not using AI just to write reports or summarize random web pages or document. They are using it to answer questions from their own private knowledge, policies, research reports, support tickets, PDFs, Notion pages, internal playbooks, product docs, and customer records. That is where RAG becomes useful. In 2026, production RAG systems are not simple PDF chatbots. They are enterprise knowledge systems connected to internal research policies, support tickets, Notion workspaces, customer records, SQL databases, and millions of private documents. Companies are using it to answer questions from their own private knowledge. Policies, research reports, support tickets, PDFs, Notion pages, internal playbooks, product docs, and customer records. The difference is massive. This matters because most business questions are not public internet questions. A bank advisor needs the firm's latest research, a consultant needs internal case studies, a support bot needs the current refund policy, a research team needs exact paper citations, and this is not theoretical anymore. Morgan Stanley built an internal AI assistant for financial advisors that answers from a corpus of around 100,000 documents and links back to source material. McKinsey built Lily to search and synthesize more than 40 knowledge sources and over 100,000 documents. Klarna's AI assistant handled 2.3 million customer service conversations in its first month and reduced repeat inquiries by 25%. So in this video, I'm going to show you the practical version of that architecture, a RAG app that searches PDFs and Notion, uses hybrid retrieval with MMR and BM205, answers with OpenAI or Ollama, shows exact sources, and evaluates itself before you ship.
So in this repo, you will find the README file. Just you have to follow every step and let me show you one by one. Um, You can make one virtual environment using this command and then activate this virtual environment using this command. And after that, you can just scroll down and copy this Streamlit .py command and run it. After running this, it will take time. So basically what it is doing, it is indexing every documents we have in the data folder. Plus we have our data in our Notion. So this is Notion where I have several documents such as this industry proof report, how companies use RAG in production, and also this RAG enterprises adoption in 2026 study. So these are my two files on Notion and some of the files in the data folder locally. And now you can see the pipeline is ready. So what I will do, I will go down here and copy this question and paste it and see what it says. So here on the Streamlit app, you have option of OpenAI and Ollama also. So let's see the first OpenAI. And so the question was, what ROI do companies report from RAG deployment? Sorry. And you can see the companies that have deployment solution, and the overall answer is here. And it is also showing it is from the Notion, which is on the cloud and not locally. And also you see uh, the similar documents from where the answer can be possible. Okay, so this is how it's work. And for the local model, you have to run Ollama. So for Ollama, you have to install the Ollama and Ollama West, and it should be running. Ollama should be running, and there should be a model to use this locally. So right now I'm using Ollama, so it will take some time. Okay, so this is ready, and let me ask same question. So you can see Ollama also give us the answer, and also it gives similarity documents like from where the answer can be possible and information is available. So so if we look our model is very small, only 2 GB of model. This is 3.2 Llama model, and it is giving very good answer. You can compare with the OpenAI. So as you can see, a smaller model with the help of RAG can give a very good answer uh, in comparison to other model. Okay, so let's jump on the code. How we are doing this? It is intentionally simple. Uh, it is loading the RAG pipeline using cache resource here, and it is simple. Just chain of question answer and showing the evidence from where it is the answer is available and which resource it is using. As we can see here, it is giving the answer, and also it is giving the evidence that it is from the Notion, and these are the documents related to the this answer. So it this is pretty much simple. The main part is the RAG pipeline, where the whole code I have divided into section wise. This is config section, and so if we go down, we have document ingestion, and same as the different section here. So let's go ahead and see the config section. We need OpenAI API key, Pinecone API key, Notion API key, plus if you want to ingest pages, you need the page ID, or if you are using database, you need the database ID. You can search on the YouTube on different. There is lots of video available how to get API key and how to get page ID and database ID. For indexing, I'm using Pinecone index, and the name is RAG Production 2026. Embedding model, I'm using text embedding 3 large with the dimension 3072 and the best quality, which is best quality for Pinecone. And also I have different embedding models. You can see I have nomic embedding text latest, which is only of 274 MB, and you can use different type of embedding model also. Okay, so if we go down and we go to the document ingestion section, you can see we are using Notion database loader for loading the Notion. This is optional, but if you want Notion pages to load in your vector database on your knowledge base, you should give this and API key. Plus, also we have a local files loader, which is loading through PyPD, PDF loader, text loader, and and the last we have document loader, which is combining both the resources, both the sources of data uh, in one to return doc. Okay. For chunking strategy, we are using chunking strategy of chunk size 512 and the overlap of 64. LLMs and the embedding models do not work well if we throw the entire PDF or entire resource of document information into one vector. So chunk document uses recursive character text splitter. The chunk size is 552 and the overlap is 64. The character overlap is important because a fact can sit across a boundary without overlapping. The beginning of the sentence uh, might be one might be in one chunk and conclusion in other. The splitter tries separate in order, paragraphs, one line, or sentence like breaks, space, finally characters. That means it tries to keep chunks readable before it falls to the hard split. After splitting, every chunk gets metadata like meta ID, meta index, and meta ID, meta index, and the character count. Okay. Section 3, Pinecone vector store. We can create or reuse the Pinecone index if not available. The matrix is cosine. Dimension will be the same as above, and the embedding models will be the same with the same dimensions as stated in the config. If it creates again, the index will be the same. And then get vector store wraps the Pinecone index with LangChain's Pine vector store. Ingest uploads the chunks in the batch of 100. The batching matters because the real documents set can create thousands of chunks. The next section is a retriever section. Retrieval section is where a RAG system either work or fail. The first retriever is a dense vector retriever. A dense vector retrieval is a list of a dense vector is a list of numbers that represent meaning. If I ask low rank adaptation, vector search can still find LoRa passage even if the exact word in the question are different. This report does not use normal similarity search. It uses MMR, which stands for maximum marginal relevance. So what is MMR? What is MMR? MMR is a diversity aware retrieval strategy. Normal vector search might return 6 chunks that all say almost the same things because they all are very similar. MMR fetch a large candidates, here it is 20, and then return 6 final chunk. Each selected chunk should be relevant to the query but do not redundant with the chunks already selected. So in simple language, we can say MMR gives says like give me the relevant evidence, but do not give the same paragraph 6 times. Okay, so this is it. Here lambda MLT is 0.6 with setting balance, relevance, and the diversity. Higher the value, lean more towards similarity to the query. Lower the value, lean more towards the diversity. Okay. And next is in the hybrid, we are using BM24 retriever. BM24 retriever is a classic keyword ranking algorithm. It is not based on embedding. It is core documents using term frequency, inverse document frequency, and the document length normalization. Term frequency means does the query word appear in this chunk? Inverse document frequency means is that word rare across the whole corpus? A rare word like QLoRa, Pinecone, or 340%, like we are seeing in the answer, are the most used in that common, or a word like the or model. So these are the common words, and QLoRa, Pinecone is a word which is not very common in the chunk, in the corpus. Length normalization means a long chunk should not automatically win, just it contain the more words. BM24 is excellent for extract term like acronyms, version numbers, company names, statistics, names like LoRa, QLoRa in this project or in this use case. In the RAG chain section, here is a prompt template. You can alter that prompt on the basis of your need, and you can also alter these. It is taking context and the question to give the answer. That's it. And in the final section of the pipeline, build pipeline builds everything from the load data to making chunk and the making embedding, storing to the vector, retrieve, and the chain. Here, it is making everything assemble to give the answer. In the ask, you can see there is two-part: retriever invoke and the chain invoke. Chain invoke will give the answer, and the docs retrieval invoke will give the docs to the LLM. And in final, you can see there is some questions for the only test purpose. You can also change question according to your data and according to the what kind of cloud platforms and your data is from, like Notion or Confluence and any other kind of platform you are fetching data from. Okay. So after that, we have RAG eval. In this RAG eval, we have question and answer. We will take question, answer, and the context of the list. Faithfulness in the float is from 0 to 1, relevance from the float 0 to 1, and the quality in 0 to 1. For the LLM as a judge, and the latency, how late, how much time it is taking, LLM taking to give the answer. Okay, so if the answer is the point of relevance or faithfulness or the quality is more than 0.7, it is passed, otherwise it is failed. Okay, so and here is a faithfulness prompt. You can give different type of if you want to alter. So these are the certain simple prompts. If you want, I can read one of the prompt. You are an evaluation judge. Rate context relevance. How well do the retriever passes answer the question? A score from 0 1 means a score of 0 1 means every passage is directly useful. So basically, it is giving the points to the relevance of the document it is fetching, the quality of answer. So basically, it will evaluate an LLM, act as a LLM as a judge, and it will also give you this evaluation report. So basically, you can see this is a question, this is the answer, these are the context, and the relevance is 0.8, faithfulness is 1. So basically, it's pass. Thank you so much for watching this video. Please like and subscribe to my channel, and please do comment anything that you liked or you disliked, or any kind of suggestion you want to give me. And please like and subscribe, guys, because it will motivate me to make these kind of video, like make more these kind of video. And if we talk about making more videos, I'm working on the same thing, but in a different way. And this is a RAG, but the agentic RAG, how a different agents responsible for the different things and come together and make an agentic pipeline. So thank you so much for giving your time. Please share this video to anyone who is interested to learning RAG pipelines or anything like agentic things, interested in the agentic pipelines or any kind of AI. Please share the video. It will help me a lot. Thank you so much and appreciate your time. Thank you.